Well, hi, good morning. Thanks so much for joining me here in my shop. It's December 9th. And the end of the last video, I said, well, I've probably seen enough of this radio. And for now, I'm going to set it aside, do something else. No, it's still on my bench because, of course, when I finish, and 24 hours goes by and my brain keeps working, more or less, and I come up with new ideas. And so also often I get messages from people, emails and stuff like that, which give me more ideas of things I can do to move forward with a project like this. So that's what I'm going to do. I'm going to move forward with it right now. So there's a number of factors here that are of interest. First of all, the radio's reception was poor. Now I hooked up a loop antenna. The loop antenna is sitting right there. Word on the street is a loop antenna isn't very good for these radios. I don't understand that myself, but then, what I have in my head isn't really reality, it's just what I have in my head. So I think some experimenting with different kinds of antennas would be of interest here. I don't have a lot of options. One of the issues is how the radio was grounded, or was it grounded at all? So it was, and I'm going to use the word, I'm going to be a little bit like British people and use the word earth, which is a far better term, because here in North America the word grounded means too many different things. So I'm going to stick with the word earth, because obviously that means something is connected to the earth. So what's this radio earthed, or did it need to be earthed while I was using it? When I hook it up to a loop antenna, one of the key things of a loop antenna is you don't need a ground. Like normally your antenna is out, in the gas, out in the sky, and you're trying to get electricity to run from the antenna through the radio somewhere. It's got to go somewhere. So you need like a counterpoise sort of arrangement or somewhere for electricity to flow. So one obvious place is into the ground, into the earth. So you drive a ground rod, I'm going to talk about that in a second, and you have your antenna, basically here's my antenna, basically feeding into the ground rod and on the way hitting the radio. In this case, there's a transformer on the antenna with a primary coil, and so that current that's flowing between the antenna and ground will flow through this transformer, be picked up by the secondary, and then head its way to one of the grids on one of these tubes. Loop antenna is very different in that you're not so much trying to pass energy from an antenna. This is a little shaky here as I say this. From an antenna into the ground, you've got a loop that's picked up the signal in the coil and has got two leads doing this. So in my mind, if you hook one of these up to the ground connection and to the antenna terminal, you should get action in the radio. In fact, it should be just fine. It may be even far, far better. That's really what I think. Far, far better than a wire antenna. But the thing about the loop antenna back here is it's very low impedance. Almost putting it dead short, DC-wise anyway, across the antenna terminals. Since there's a transformer involved, maybe it's messing up the operation of the transformer by putting a low impedance connection right across it. I don't know. I'm just trying to figure out why people think, or why things work the way they do, or people think things work the way they do. So we can experiment with that a little bit. As for an earth ground, now I'm sure you're watching my channel. You know something about this already, but typically an earth ground is done with a rod. You hear different things about this. You hear pound the rod, got to be at least 10 feet long because it's got to get down into the damp soil. Well, where I live, the damp soil is a foot under the ground. It doesn't have to go down that far to reach damp or permanently damp soil. I know a little bit about this from my past in the power industry, as I read up on ground rods. Ground rods are very important items for maintaining safety. In a power distribution system, what they're really doing, the ground rod is connecting the earth to the electric system. And if the electric system the neutral of the electric system. If the electric system neutral should be driven into a high voltage condition, maybe from a short circuit or some kind of failure, or wires on poles crossing, all kinds of stuff can happen. This, the neutral wire, and that is exposed to people all over the place in an electrical environment. In fact, all the cabinetry, everything is connected to this neutral. Well, if the neutral should shoot up in voltage, and you're standing on the ground and you touch it, you're in trouble. There's something called touch voltage and step voltage. You can almost picture these. The touch voltage is defined as the voltage drop across about a meter of ground. A voltage drop across the ground. This is something you need to realize, that there is such a thing as voltage drops in the earth, in the actual earth. So touch potential says it envisions a person standing beside a fence, like a station fence for a power station fence, standing about a meter away, maybe leaning on the fence with their arm like this. I've probably done this at some point without much thought. Should a fault occur inside the power station, usually talking about very high voltages, it's possible for you to get a shock off that fence. So they do studies in mathematics and engineering, and go up and make measurements and things like that to try to make sure that under certain conditions of fault, the fence doesn't rise too much relative to the earth about a meter away. There's another one called the dog on the chain, which is not a commonly used idea, but the idea there is you're walking your dog and you got them on a chain. Now, I don't know how many people chain their dogs and walk them, but the idea is that you got a metal thing. So your dog is walking 10 feet away and you're holding on. Now there's 10 feet of earth. There's a much higher voltage potential. Voltage could occur there. Sounds crazy, but these are things that are thought about. If you don't work in the power industry and never heard about this kind of stuff, this goes on. So typically a fence touch voltage is allowed to rise to some thousands of volts during a fault. Now, normally power system faults last 5 or 6 cycles in a 60 cycle system, 5 or 6 cycles before protective equipment operates and arcs are snuffed and everything goes dead. So you have to survive the voltage for that length of time. All this stuff has been calculated out and so forth. The step voltage is the distance between your feet. You may have heard about this with lightning bolts, and you're told, man, if you're in a lightning area, don't stand with your feet like this, stand like this. Well, you know what, if you're watching some high voltage work happening and you're standing next to it, you should do the same thing too. And this, my own advice for if you're not knowledgeable about this stuff, and you see a overhead wire has come down on the ground, maybe during an ice storm or windstorm, or trees knocked it down, or really the classic one is somebody crashes their car into a pole. The pole falls right over and all the wires come down on the ground. You shouldn't go anywhere near those wires. In fact, wherever you are, you should just go further away. You should not go towards them. A couple things can happen. One is they can be live. Usually they'd be sparking and arcing, so you probably know that, or smoke would be coming off them and stuff like that. You know that these wires are still live, touching the ground. As you approach them and you take steps, you get a higher and higher voltage between your feet. So if you're out in bare feet, you're in big trouble. If you're wearing rubber boots, well, maybe it doesn't matter, but who knows, right? But a lot of innocent people, children and that, could approach a situation with a car wreck and somebody injured, and they come running up. Everything is dead, no sparks, no smoke, everything looks dead. Meanwhile, back at the power control office, the guys are scratching their heads about another outage on this line. Oh, it's probably just a branch touched a wire briefly. Let's re-energize. And maybe in a minute or two, the power will come back on. At that point, where are you standing? So this all has to do with voltage gradients in the ground and the size of the electrodes that are touching the ground. So forget all that other stuff I just talked about. Let's get right to the ground rod situation. Could you use this as a ground rod? Well, yeah, lots of conditions you could use this as a ground rod, but it has a couple problems. It's short, obviously. But the main problem is there isn't much surface here. There's not much surface. you put that in the ground and you expect electricity to come off of it, which is kind of a weird statement, but let's go with that, electricity coming off of it. And you could think of the earth around it as a series of shells of earth. Let's say every one is an inch thick, a bunch of inch thick shells of earth around it. And electricity has to flow through those shells. The first shell is very small, right? It's very small, tight, right around the post. All the electricity has to get through that 1-inch shell. How much dirt is there? Well, not very much compared to just a few inches away, where now there's a lot of dirt. So the resistance of the soil is going down in a sense as you go away from it. This causes a gradient around the rod, which would be shaped something like that. Something like that. That's why if you go into a transformer vault or an electrical environment, a power station, or anything like this, you'll see there are many ground rods, usually driven around the perimeter. Let's say this is a transformer vault, big enough, big transformers in it, people climb down a ladder or walk around inside it, a great big transformer vault. There are thousands and thousands of these all around the world under the streets of cities. And people go in them regularly. You find in each corner a ground rod has been driven. Well, why not just make one big ground rod? Why have them in the corner? Because the idea that the earth is at 0 volts is totally wrong. You can't think of it that way. The earth is just a really weird resistor. Okay, great big thing. So you put the rods all around it. So should a high voltage line touch the neutral and energize everything in the vault that people can touch, all the cabinets, everything, the ladder, everything, these rods will force the earth to come up in potential to meet this high voltage. And there you are standing here in the vault, and the ground around you has all risen up to the same voltage as the cabinets. So you're touching a cabinet, which you probably would be, or something metal, and you're standing on the ground, which you probably would be, you wouldn't experience the full voltage, and you're made much more safe. These things are calculated out, worked out. How many rods do you need? How big do they need to be? And stuff like that. In a heavy industrial environment, there's equipment to pound rods into the ground 10 feet and all that kind of stuff. Not so much for us in our backyards. So the key thing is to get a low resistance connection to earth. The long rod is the hard way to do it. The easier way is the big round rod, or in many cases you've probably heard about a plate. Bury a plate in the ground. You'd have to dig down and bury it where it's definitely a little bit moist all the time. You'd also want to backfill that very carefully, because once you disturb the earth, you cause all the soil particles to separate. The resistance goes way, way, way up. So you don't dig a hole, put the rod in, and then backfill. That's not good. You want this surface to be pressed up against the soil. There's just a whole bunch of things that are coming to my mind here as I'm talking. So I do not have a ground rod in my house. I have never bothered to do one. My yard is basically, I live in a post-glacial area. All of Canada is a post-glacial area. The area around me is only 8,000 years old. Prior to that, there was a mile of ice on top of here. So the soil here, where I am, in particular where my house is, I'm on the side of a hill, is just stones and gravel with some soil thrown in. It's really what it's like. If you go out with a shovel and try to dig a hole in my backyard, clink, 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 you're just hitting stones this big, little stones, and gigantic boulders. There are gigantic boulders. If I could take my camera outside, I could quickly show you huge boulders in my neighbor's backyard and my other neighbor's front yard. I don't have any boulders on my property, but so getting a rod in the ground is really tough. So there's no guarantee pounding a skinny, 5-foot rod down on the ground is really going to give you the kind of ground you might need. You got to consider the soil where you are in that. The bigger the pipe, the better you are. And it gets kind of the same effect if you put in multiple ground rods. you end up with more and more surface, and together there's somewhat of a combination effect going on. So that's the story. The earth is not 0 volts. Grounding things doesn't keep you safe, and it's safer. So okay, now my situation. What am I going to use for a ground if I'm going to try to do this? I have 2 options. One is the one I actually applied here without much thought or conversation about it. I hooked it up to my power supplies here. Most of them, not all of them, have a 3-prong plug. That 3-prong plug is bringing the hydro neutral in my house, or the ground wire, better call it the ground wire. The 3 wires, you have the hot wire, the neutral wire, and the ground wire. It's bringing the ground wire right up here. Now where's that wire go in my house? Well, first it spiders out all over the place. It basically goes back to my fuse box. It's just in the next room here. And then it's paralleled or extended out all over the house, of course. Everywhere I've got power wires, I've got this ground wire going. And but from my fuse box, there is a wire which runs to the water pipe where it comes into my house. There's a short distance away again, just in the same room next to me. And so there is a connection to the earth. Now that's a sad attempt. Well, really, let me back up. A lot of people think that has something to do with connecting your electrical system to the ground, but if you've been following what I'm saying, if you really want to try to do that, you need to put ground rods all over your property. So no matter where you're standing, the ground will be at the same potential as your electric system. If there's a fault, this is a fault. And what are we talking about? 120 volts here? I mean, we're not talking about 13,000 volts or something like that. Like in the power system situation, we're talking very high voltages, very, very dangerous circumstances. Not so much here. So the wire goes to my water pipe, but not so much so it's connected to the earth. It's to ensure the rest of the water piping in my house doesn't float at a higher voltage or lower voltage than the ground system that's running through the house in the electric system. The idea here is, if you didn't connect your water pipes, let's say you got a plastic water main. A lot of houses have plastic service pipes now, and even plastic water mains. So if it's plastic, then the plumbing in your house, which let's just guess it's metal, it's old enough to be metal, is essentially a big electrical thing, a big electrode, if you like, just floating in your walls of your house. It's not connected to anything. So what if a wire in your house should touch it, a hot wire? What if the hot wire should touch your plumbing? Well, nothing would happen. Nothing would happen until you discover it by touching it yourself and somehow grounding yourself. This is a big danger. So to ensure that the plumbing never goes up to 120 volts and waits for you to get zapped, there's a wire that runs back to the fuse box. So when the short circuit occurs, a fault current will flow sufficient to pop the fuse or open the breaker. Well, one of those two. That's the real goal of tying this stuff back to your house plumbing. Oh boy, I really didn't plan on talking about all this stuff, but I am. So my option here is utilize the ground that's provided here in my shop through the power system wiring in my house, like I've done already, or run another wire about 20 feet, 15 feet to the water service pipe entrance and bring a separate wire in here from there. Now how would that be any different? Because I mean, it's the same pipe, so one wire is sneaking through my electric system and the other wire is just coming on the floor here. What would the difference be? Well, as much as you don't want current flowing on the ground wire in your house, all the current should be flowing on the neutral and the hot wire. You shouldn't have any current flowing on the ground. There's bound to be a little bit there from something. Now that little bit sets up a voltage difference, and from the outlet to the real earth, and utilizing that ground, I suspect, could make a radio like this hum a bit. I'm not sure of that, but I think that's where one hum could come from. The voltage drop in the ground wire coming out of a shop like this. So if I run a wire separate from here to the water pipe, that current won't be on that wire. So that's my thinking. So would that make a difference? I don't know. I don't know. So I hope this is making some sense. This topic, grounding topic, if you want to understand it well, I would suggest you grab what's called the IEEE Green Book on Grounding. This is one of the few books I've read that lay it out so you cannot fail to understand this issue. If you have in your head that things like if it's grounded it's safe, or the earth is 0 volts, if this is what you got in your head, it's not quite correct. And if you're doing this kind of work, you need to get a little more in your head on that, I think. Maybe not as much crazy stuff as I have in my head, but so okay, so that's one thing. Fooling around with the antenna in the ground, seeing what it does to the radio. Next thing, there is a detector in here. I'm using an O1A. Someone mentioned to me that the low voltage of 22 volts is really intended for a different tube in here. But you can use an O1A, 201A if you like, in this position like I've done. And boy, that raises an interesting question about this. But let's stay on one topic here. These tubes will detect better at a higher plate voltage. So I had this guy at 22. I could raise him up maybe up to 40 or something like that. Just looking at my power supply, I'd have to do a little monkey business with my power supplies to get there, but I could do it. That might clean things up a little bit. Might make the radio receive better. Yeah, I don't know about that. Another one that's of great interest here is the grid leak resistor that you see here. Making high resistance resistors back then was, I guess, a tricky business. I've got one right here we can look at. So inside this one is a black rod running through it. Now what is that black rod? Hard to say exactly what that is. It could be rolled up carbonized paper. I don't know what it is exactly. But it's some kind of material that can present a high resistance. These are fairly fragile guys. You can't be putting too much current through them, but they're very high resistance at the same time, so it can be a bit of a challenge to do that. These things go anywhere from, I don't know, 500,000 ohms to 10 million ohms. I don't really know. But there's a reason why it's in a clip at the top of the radio here and easily accessed. Because you may want to change it. If you tune in a strong station, you may find you got to change the resistor to compensate for the effects of the strong station. So people, I guess, back in the day, right around this time, 1925, would have a number of these resistors that they could use to try alternately, if you like, or to try different resistors. Just pop it in and see if it cleared up the sound any. Well, I've got quite a few of them here to experiment with. I've never done anything with these. The other thing is I have two more very old 1920s radios. Great big honkers that take two people to pick up on spindly legs from about the same vintage as this one. They're bound to have these in them too, I would imagine. So look at all that. So I have all these to experiment with in this radio to see if changing them somehow improves the operation. So I've got the antenna, I've got the voltage here, I've got all these. There's another thing. When I tuned the radio, I tuned it up one way. It seemed to be more sensitive. As I tuned it down to the area where I wanted it, because there's radio stations we're getting, it seemed to get quite a bit weaker. You know, my guess at that, it's an alignment issue in this radio. Now most radios have trimmer capacitors and all, you know, they're really set up to be adjusted and tuned, but I don't think this one is. I think the idea of this one was the factory does what the factory does, and the radio gets sold, and the idea of doing an alignment is just out of the question afterwards. So when I look in here, I don't really see any obvious capacitor as such, but what I do see are these little nubbins down here. Let me get a better pointer. This guy right here. There's another one here. See it? And another one here. Same thing on the other side. Now, what are those things? So I'm sure you and maybe not, you may be very experienced with these, so you know what those are, exactly what those are. I believe they are involved in alignment of the radio. What exactly are they doing? Is there a capacitor down there? Or is it manipulating the dimensions of this somehow? I don't know. I can't see it. This guy looks as rigid as can be. So what exactly is down there, I don't know. That's another thing that's worth looking into for sure, for me, to find out about them. They don't look like they're easily adjusted once radio's been assembled. So my guess is they build this thing, and then they have a jig, and they adjust those guys down there, and then that's it. And then this is put in the radio, and that's it. Away she goes. Could be wrong about that. I mean, they could have some kind of tool that gets on there, and you can do something with it. Pretty awkward. This side's got a little more clearance. But pretty awkward to me. And I don't know. Is that really how those work? Another thing to look into. So another couple possibilities here that could be causing poor reception, and not the least of which is I'm in my basement in my shop, which I know from experience this is one of the worst places you ever want to be to try to run a radio. These capacitors here, whose purpose I'm not clear on because I really haven't looked into it yet. Maybe there's something going on with these. Maybe they've lost their capacity. I don't know. The capacitance is very much based on the dimensions of something like that. The material inside here, the dielectric material, maybe a little less so, in a sense. Don't know. Don't know what. Don't have the experience necessary to know the answer to all these questions. And are there more questions? Yeah, probably are. Probably are more issues with these old radios. I haven't figured them out yet or realized them. I'm also really suspicious about this resistor here, which we're going to measure right now. Why is this in a thing you can pop it in and out? This can't be the grid leak resistor. This is the grid leak resistor. There's a capacitor associated with the grid leak somewhere in here. We got to find that capacitor. Is it this one? I doubt it. I think there must be another one in there. We need to find that and sort that out too. Let's take a look at the resistance of this guy here. Now, I think it's very low. Reading very low resistances is not easy. I'm going to try to put myself in the best position to get a decent reading here. Uh-oh. The things I was looking for, they are missing. I'm looking for a couple of clip leads here. How did they go missing? Uh-oh. Okay, we'll have to use the regular leads. Oh, here they are. Here they are. Well, how do you like that? Sitting on this meter here. Now, this is kind of a meter you use for automobile work more than, I think, anyway. 200. Well, I'll go to 200 ohms. That's the same as my other meter. Let's just go ahead and try this. I wanted to use the clip leads because they're just a little more certain in the connection. First, we're going to clip them together. Now, it's hard to see how the resistance of this could be anything other than what it is. I mean, it can't. What could happen to it? The clips in here and the connection in could be a big deal. Yeah, open circuit. So let's do this right. Let's do this almost right. There we go. this is kind of useless, isn't it? That should be 0. Oh, yeah, that's useless, all right. There. That should say 0. Where in the world is certainty? Man, sometimes it's so hard to become certain about something. Yeah, and I'm going to try to, this is pretty useless, isn't it? Oh, yeah, right, should be a short. Maybe my leads have given up the ghost here. Oh boy, okay, this isn't working. Not only is it difficult to read a low resistance, for me it's difficult to read any resistance here, holy smokes. Okay, I'm going to do what I've been trying to avoid, which is use these long leads. So 0 is 0.2 today, 0.1, 0.2. 1 ohm. 1 ohm, as long as it's making good connection. It looks to me like that clip is pretty good. I don't think there's anything to gain from fooling with this resistor. It's all about that guy. So, order of operation here. What are we going to do first? Well, we should try the least impactful thing, which is fooling with the antenna. So I talked about the ground. Now, the antenna situation in my house, I have, it's actually, there's a bit of a story here. I have 3 main antennas outside. 2 of them are folded dipole antennas with impedance matching transformers, just those little TV ones, and a 75 ohm cable coming back into my house to the other end of my house where I have the room I hang out in, where my radios are and stuff. They don't hang out in my shop. So then from there, another cable comes all the way down to my shop here. So there's an awful lot of feed cable and some joints and connections and switches and stuff all along the way, but that's what I got. So that comes into my shop on a 75 ohm cable and eventually arrives at the end of these 2 clip leads. Now, this raises some interesting questions. Is this just tied to the hydro ground in my house? Yes, it is, because the equipment it's running through and by and connected to, the outside of the cable and all that stuff is grounded to the power system ground wire. So this is grounded to the power system ground wire. And you can think of the ground wire as a lousy antenna. One end is in the air and the other end is hooked up to a water pipe. And this is hooked up in the middle of that somewhere. So this could be a big source of hum, and I'm pretty sure I've done many things in my shop here. When I hook up the ground, you can hear effects. And where's all that coming from? I think it's from that kind of thing. So folded dipoles are balanced antennas. And so this is a little bit like the loop antenna in that on the wire here, this is going on. Except one side is grounded by accident. So we get this going on. I'm not sure how to use this exactly. If my third antenna is a ham radio dipole tuned for the 20 meter band, and I discovered a few days ago, as I'm getting into my ham hobby in the winter here again, that antenna is a piece of crap. So now I'm using the folded dipole antennas, which are random length antennas. I built them out of that flat TV wire, just hanging outside. flat TV wire hanging in my backyard. Not terribly appropriate for a ham radio. But these days, if you're in the ham radio, by the way, there's a lot of digital modes now that require very little power to be used. Very little. So I do my hamming at around 5 to 10 watts of power. 5 to 10 watts of power, you can hook it up to almost anything. It's just not enough power to be too worried about. But I do have an antenna tuner, and I do all that tuning stuff and that. But so I'm able to use the folded dipoles. It turns out they work really well on my ham radio. They're supposed to be for short wave and occasionally down here. So that's what I got here. So conceivably this doesn't touch anything except goes straight out to a folded dipole. Folded dipole basically goes out, comes back, comes out, comes back, and connects to this guy. So this isn't even really a wire hanging in the backyard. I think I say that quite a few times when I'm in here working. It's going to an outdoor antenna. I don't really explain it, so it's a balanced antenna. So even this might not stand up to the kind of antenna that this thing's looking for. I got quiet because I don't have an alternative. I don't have a simple end-fed wire hanging outside to use. So can I set up the ideal antenna arrangement to make this radio work? I don't think I can do it, but I'm gonna try to come close. So now, in terms of removing the power system ground from here, I can't do it because I'm using power supplies that are 3-prong plugs, and I'm not about to isolate them. I've been through that whole issue of should your shop be isolated, should it not be isolated, should you put an isolation transformer on your scope, should you do all this kind of stuff. I've been through all that, and my conclusion was I'll use an isolated power source. There's an isolation transformer driving this. Not this guy, there's another guy behind it, another transformer behind it. But even this, although these two terminals now would be totally isolated, there's no hydro neutral as such coming in here anymore. And this ground thing, well, it doesn't go anywhere. The pin is just sitting there. There is no ground coming up either. Lost my thought there. Oh my gosh. I forgot what I was going to say. Okay, if it's really important, I'll remember again where I was going with that. Oh yeah, I know where I was going. I did remember. See? Plug stuff in here, like this radio is not plugged in here, but a lot of radios plug in here, and then you think, oh, the radio is isolated from ground, and that's basically true until I hook up one piece of equipment. And as soon as I connect a piece of equipment, there's a ground on this radio, and this isolation thing is all for naught. So lots of stuff to understand here about grounding, earthing, the neutral, the hot wire. All these things need to be understood if you're going to try to maintain your safety in a shop like this. I've learned a lesson too many times that even when you think you got everything understood, there's still some sneaky way to get a shock in your shop. So the other thing I've done is that I have a lot of old vintage equipment that I'm trying to utilize. I'm trying to run like a vintage shop, if you like. A lot of the equipment is just 2-pronged, like this. Like this meter just has a 2-prong cord on it. Well, some people would take that, put a 3-prong plug on it, put a fuse in it, all kinds of stuff. What I decided to do is to continue to use the 2-prong plug. Do the quick study of which way you're plugging it in to figure out which way produces the lowest voltage on the case. If everything is in really good shape with a high impedance meter, you're going to measure 60 volts on the case no matter which way you turn the plug. Sometimes that's not the case though. You may plug it in one way and get 90 volts one way and 30 the other. So plug all the stuff in carefully to make sure all the 2-wire pieces of equipment have the lowest cabinet potential. At the same time, I've serviced all this equipment except this guy. So So I've gone through and checked it all and changed capacitors, whatever it is I did to it. So if you were to measure 120 volts on one of these, it's time to be very, very cautious that something's going wrong in there. But to get rid of the 60 volts, I've run a ground bus. You can see a little piece of it here, this green wire, and it runs around, and then little wires go up. There's a yellow one right here, and tie onto the cabinets of the two-prong equipment. So everything in here is grounded except the product until I ground it. That's kind of the way I operate. How does that play into all this? It means, well, for one thing, is since I'm operating a grounded shop, I can't get the hydro ground off of this. Now, when this radio, back in the day when it was operating, would it be isolated from the power company ground? Almost certainly, yes. Back in the day, I don't think they had the three-prong system. I don't think they understood connect your cabinet to a ground wire and everything else to the, to the, the two power wires. I don't think any of that was happening back then. So probably without much thought, this thing would be operating with no ground at all. So you have to get a ground to make the antenna work. You'd have to drive the rod or use your water pipe like I could, or no ground on this thing. Is that absolutely true? Well, not quite, because one of these two wires is grounded. Coming in, one of the two outlet wires, not these wires, one of the two wires going to your outlet. Yeah, you have the third prong ground wire, but then one of these two is also grounded. The thing about the ground wire here is it's carrying current. It's carrying as much current as this wire. It's carrying a lot of current. There's a voltage drop on it. You would never want to use this as a ground for a radio like this, or this as a way to connect to a ground, a remote ground somewhere else. So, by the way, getting back to grounds, now you're driving around, you're looking at the hydro system, and you see some poles that are very complicated at the top, a lot of stuff on them, a lot of switches. You might look and see a switch. Some of the switches are operated from the ground, and you'll see the pole, and then there's a rod coming down the side of the pole, and then you can see what is obviously a big switch handle. Usually, it's a big long thing like this, usually locked down with a padlock so nobody can fool with it. And if you were to turn that switch, then the switch up the top of the pole will operate. And what are you operating? Usually you're operating a high voltage switch. It might be 4,000 volts or 8,000 volts or something like that. If something goes wrong, you're holding onto this rod, and the steel thing goes all the way up to the top, up where the action is, and you're holding onto it. Now you're standing on the ground with your year-old boots. I'm picturing you to be an electrical worker. Year-old boots with cracks in the leather, and you just walk through a puddle on the way there, and there's water everywhere. And besides, it's 4,000 volts. It's gonna jump a gap like that. You're gonna blow your feet off. You're gonna blow your hands off if something goes wrong. So here's what they do. So at the bottom of those poles, many of them, there is a steel mat, and the steel mat is connected to the power system neutral and connected to the ground somehow. There's a rod in the ground, and this mat is sitting there. And when you walk up to operate the switch, you step onto the metal mat. And sometimes it's all overgrown with weeds and stuff like that. You can hardly even tell it's there, but it's there. Maybe some utilities actually bury them in the ground right below your feet, and that's to ensure your feet never have a different potential than your hands. If there's going to be a fault and everything's going to go up 3,000 volts, everything's going up. Your hands are going up, your feet are going up. There's no current in your body. But it costs money to put those mats out. So most guys, most people working in the power industry who are doing troubleshooting or stuff like that, trouble crews or whatnot, or switching people, going out and throwing these switches, in their truck they have a portable mat, and they bring out the mat and they throw it on the ground, And there's a big cable coming off with a big clamp, and they clamp it. They step on the mat and operate the switch. Yeah. People steal that stuff. People steal the safety stuff. They're looking for the copper wire and they steal it. So, all issues for people in the power industry. If you're a lineman or something like that, you know all this stuff. You've heard all this stuff. You live with it every day. But for people doing occasional radio work, the grounding thing is a big mystery. So once again, the IEEE Green Book on grounding is, I think, one of the best sources of factual information explained well, to open your eyes to all these concerns about current in the earth. Wow, I have just talked myself endlessly here. Holy smokes. Okay, so first move I said was the antenna in the ground. First thing we'll try is we'll just try my antenna here. I'm gonna have to go and throw some switches. Oh my gosh, 45 minutes of talk. Oh, I almost need to apologize for all that. So I'm gonna liven up this guy. It's not the best word to use for it. I have to go throw an antenna switch to turn it on. And we're going to hook it up to this radio and see if it doesn't work better with that, and various combinations of this, that, and the other thing. And we'll see what happens. Wow, I can't believe I talked that long. In my head, I thought it was about 10 minutes. Okay, now, this is going to the radio. This is coming from my antenna. Put them down. We're going to turn this guy on. There's an order here. We'll turn on the heater first. There we go. Okay. It's a bit of a battle. Switch is off right now. Very dry in my house here. Okay, we're going to switch on the battery. Okay, next thing is power supplies. Give it just a minute. That my DC power supply has a vacuum tube in it. Give it a moment. And I've got to change. If I'm going to drive the voltage up higher on this tube, I'm going to have to change my power supply. Let's leave that out of the picture for now because I'm so far into it. Let's talk about this. So this is a mercury rectifier tube. Maybe not mercury. This is a gas rectifier tube. So cold cathode. There's no heat in this tube. Just some gas in there, and it still has the rectifying effect. And this was stuck in where you need a rectifier. So I wonder if maybe this isn't as dumb as I thought it was. This is a BH tube. Or maybe somebody had a notion that this would work. Stuck it in there. I don't know. Okay, we're ready for some B plus action here. And we're going to raise it up. Didn't I have this hooked up to a voltmeter? I did. We want to keep track of this voltage. It's very important. Oh, gotta wait for some more tubes to warm up. There we go. Okay, so we're going to raise the voltage up. I had it around 80 yesterday, I think. 50, 80 would be about halfway up here. Okay, we're raising her up. That's about 80 volts. B plus. Now we're going to bring on the detector. Bring on the detector. Up. Oh, we're on current. Whoa, whoa, whoa. Okay, so I can put this up around 25 volts. This tube has to be depressed a bit. I think it might be okay like that. Okay, time for the antenna. Where's the antenna? The antenna lead is here. What happens if I just fool with it? Doesn't do a thing. I think that would... Oh. I think that would do something. And my other antenna lead. Okay. Strange. Okay. You know what I did? You know what I've done? I know what I've done. I know what I did. I've mixed up, because this diagram, I've mixed up the antenna and the ground. That's what I've done. I'm pretty sure. So let me just... So the antenna should be that side. Oh my gosh, that whole thing's turned around. Okay, turn it this way. The antenna should be that side. Yep, I got the ground on there. Okay. Man alive. All that talk. That's what it turned into. I don't want to fool with this with the power on. So I think I'll just take the B plus down. And the other B plus down. And we're going to switch these around. Well, that means I've got a ground on... Ooh, what does that mean? What does that mean exactly? Ground on the antenna. So there's nothing but a coil between the ground and the antenna terminal, and I just stupidly hooked the ground up at the top of that antenna coil. Oh my gosh, this came right out. Yeah, I should have turned the power right off, but that's okay. Here we go. Now I got the ground on. Oh my gosh, this is going to work a lot better. I'm going right back to the loop antenna, because I don't understand why it didn't work. The loop antenna should be able to relieve me of all these ground issues. That's what I think. But let's give it a try. Okay, so I'm going to hook it up here. Okay, so we have the loop antenna connected, wires straightened out, B plus coming, B plus up around 80 again, B plus at 80, and now detector. Sounds worse. Let me disconnect that antenna. Where do you think that hum's coming from? Okay, outdoor antenna. What happened? We were better off the other way. What gives? 80 volts, 25 volts. What gives? Did I jump there and actually I've got it backwards now. So this is upside down this way. No, I've got this connected according to this diagram. According to this diagram, if it was this way. The tube came off. Okay, hook up an antenna. We need an antenna. We're doing this kind of stuff. Loop antenna for fun. Loop antenna's a nil. Sorry about the hum. That was better off the other way. What can this be? Pretty shaky everything. Shaky, shaky. Open antenna coil. Open antenna coil. Is that possible? It's definitely possible. It's definitely possible. We have to shut everything off to look for that. Ooh, that noise. We don't need to shut anything more off than that. So, did I check this? Can I even check this? This is another potentially fairly low resistance here. Yeah, fits right in. Okay, just do it like this. Pretty sure there should be no voltage there. This is open. 200K. Well, there's something there. I saw 8 for a moment, but I can't hold still enough to get a good reading, but there's definitely something there. Okay, so it looks like the coil is not open. Well, so what happened that I switched? Huh. How could this be? Why don't we work straight onto those terminals? Well, this is just a pair of wires coming here. It's really not, I mean, it's just, there's nothing spectacular about it being coaxial. Well, I'm not going to hear anything right now. I've got to put the voltages back on. 80 there. It was working and then I fixed it. Okay, let's do this. Let's, what should we do? Oh, that might explain it. The other end of my cord fell off. That would explain it. Let's, wow, okay. You never know. Oh, come on. Come on. Come on, come on, come on. How can this be? How could it have worked just a minute ago? Because the tube's not pushed down. I've got too many things to hold on to here. Just gonna clip this. This. I'm going to take the other end. You hear a thing when I did that. I think I hear it very, very faintly in there. Well, let's put these wires back the way they were. Hey. Just turn down the detector to B+. While I do this. Wonder what 80 volts feels like. What's 80 volts feel like? Maybe I'm gonna find out. Oh, jeepers. I don't want that to happen. Okay, come right out. Come right out. This one won't. These nails are a close fit in there. Stick it in with your finger. I shouldn't be able to get a shock, but you know. Everybody hooked up there? Now what am I doing? So now I want to skip this cable. This is the antenna lead. It's still connected. And go right on here. Oh, 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 oh. Oh my gosh. Hey, I should have left well enough alone. Son of a gun. Will these other tubes come off? I don't think so. These look pretty darn good. What's that? It could be the heaters coming off of this tube, and it takes a moment to heat up, and I'm not giving it enough time. No, I don't think that's the deal. Come on, the radio was working there for a moment. I don't get it. I don't get it. Let's go back. Jeepers, you know, I just... That's antenna and ground. Hooked up to nothing right now. Hooked up to the loop. I seem to have killed it. Why did you do this, radio? Well, let's just put it right the way it was. So, I had this backwards, but it didn't really matter until I hooked something up to it, because it's just okay. This is going to be I'm losing control. Jim's losing control there. Okay, losing control. I don't know what that funny sound was, but I don't like it. I don't like it. Sorry, I just banged the microphone with my head there. Okay, so it's the way it was when I came in. Ooh. Something wants to oscillate. Well, you know, I've been going for almost an hour here without drinking any coffee. So I think I'm going to shut this off, get rid of the high voltages, and go drink some coffee and ponder what happened here, because how it stopped working beyond me right now. And I'm over an hour. I'm over an hour already. Okay, a couple more ideas. One is proof out the ground again on these two antenna and ground terminals, just to be sure. I think that's the ground, and I think that's the antenna. A little hard to tell. This is ground, and this one must be the antenna. I'm measuring the resistance of the antenna coil. That's the antenna that way. That matches what I've determined about this. I'm going to hook up my signal generator to it. And Mr. Short-Term Memory. Antenna. And ground. Okay, let's so I've got my signal generator going already at 590 where the radio is tuned roughly. Take this out. Okay, now we're going to power it back up again. Switch is off. DC supply is on for the heater supply. Heater supply is on to the radio. B plus. $80. Detector. How do I do that? Volume control. 20 volts. Press the tube. Give it all it's got. What has happened here? Well, once again, 80 volts. Double checking everything, yeah. 20 on the detector. It's a little more, close to 30 on the detector. What happens if I reduce the B plus here? Oh yeah, it's definitely working. So I'm touching one side of the grid leak resistor, and you can hear a hum come out of the... You can hear a big hum coming out of it anyway. Well, oh, that's different. I don't like doing it, but reverse these to the way they were, backwards. Oh, jeepers. The problem with my nails is they can fall out and fall down and short everything out. And nail system's a little bit scary. So I'm going to put the antenna connection backwards, what I believe is backwards, the way it was. And I got it to work a bit. It just seems totally stupid. Okay, back on. Back on. And back on. Big strong signal. I thought the radio was more sensitive up here. Why don't we go way up here? And I'll just advance my signal generator up there. How do you like that? Okay, let's switch the antenna now because it's supposed to be the other way around. Okay, switching off all power supplies again. I don't like doing that, but when I'm fooling around with this crazy arrangement I've got here, like I mentioned, one of those nails can fall out. I've had this happen already. Fall out and just fall to the bottom, and then it's ready to short across anything. It's really a very precarious arrangement I have here. Okay, so now I have these. I have these the wrong way. I have these the wrong way. Okay. Power on. B plus up. B plus up. Okay. I wish there was an easier way for me to switch these. Leaving the set on. And what? Feeling reckless. That's what. B plus, B plus. Oh, I didn't push this down. Oh, that was a mistake. Okay, tune it in again. Come on. Jeepers creepers. Radio tuned in the right spot anymore. Wow. Reverse them again. Let me just cut the sound down like that. Okay, take your time here, gentle. You know what's happening is I'm starting to rush. That's one of the key factors in making mistakes. Rushing. Yeah, the other factor is just being stupid. Okay. Back up here. It seems like I get it. Oh, yeah, push it down, push it down. Got it. Let's play around with this tube here. Just to barely touch it. Just a little bit of weight on it will do it. There we go. I knew this meter would be useful someday. Now, so now these wires are connected backwards. Now we got to get in there and without disturbing this, switch them back around. You can barely hear this too. So where'd it go? Coming and going. Oh. Who is it? Which one of these is doing that? Okay, don't anybody move. So I currently have this hooked up backwards. Let's take the ground off. Still hear it. What a situation. one. Probably the ground should get louder. Bingo. Okay, baby. Yeah, that's the best it's ever worked yet. Let's go back down to the 590 thing. I'm going to chase it down there with the signal generator. Juice coming out of it on this band. Chase it down. It's fading out. Wow. No wonder I'm having trouble down there. Let's go back up. Come on, keep going. Way up here. Go way up there. What can we do now? Leave it all alone. Yeah, okay. Wow. Oh, what just happened? How come it got quieter? This meter's no good. That's beautiful. Maybe is that why I couldn't get it down below? Chase her down there. Okay, I'm not going to chase it this time. I'm going to go down there. That's roughly 590. Should have chased it. Well, I can still hear it, but barely. It's just getting weaker and weaker as I go. Okay, that's the end of the road for today. That's the end of the road today. Oh my gosh. Well, so I talked an awful lot at the beginning of this video, and I'm not sure I've left it in or not, because things have gotten so long. So seems to me, well, I don't know why. Why would it be lower, so much lower at the lower frequencies? Some kind of alignment issue? I don't know. I don't know. Okay. Hey. Yeah, that's why you can't buy these radios anymore brand new in the store. They've moved on from that technology. That's for sure. B plus down. Yep. Switch off. Yep. Okay, well, thanks a lot for watching that crazy nonsense there. Not sure I proved much of anything out. Except I did prove one thing. The radio is very insensitive at the lower frequencies where I've been trying to use it. And that's the only place there are stations that I can pick up during the day is down at the lower end. I'm going to try to receive an actual station. It's going to have to be like above a million hertz, and there's nothing up there during the day. Oh boy. Well, thanks a lot for watching. I apologize for the whole thing. See ya.